Hello everyone, let's take a look at our next problem. Evaluate the integral from 0 to 1 of the cube root of 1 minus x to the 7 minus the 7th root of 1 minus x cubed. So my first thoughts are this is a pretty messy expression. I don't immediately see a substitution that we could make. Maybe we could raise things to certain powers and see what happens. Maybe we should interpret this as, okay, so like, x is between 0 and 1. So both quantities beneath the square, or beneath the root signs are also going to be between 0 and 1. Maybe we interpret this as some appropriate, the area of a subset of a square. 1 minus x to the 7 to the 1 over 3 minus 1 minus x to the 3 to the 1 over 7 dx. Oh, wait a minute. Wait a minute, will this do anything? So it looks a lot messier than it is, because when x is 0, this whole thing is equal to 1, and when x is 1, this whole thing is equal to 0. So if I do a substitution which sort of implicitly changes the order of integration, maybe that'll help. I mean, I think I'm going to end up just trying a few different things here and hope one of them actually progresses into something. Okay. Okay, I think I have an idea here. If you followed some of my rough notes up here, I'm just going to interpret what this first quantity means geometrically. So if I plot the function of x that we have in the integral there, well, x to the power of 7 is increasing. So 1 minus x to the 7 is decreasing. And then when I take a cube root of that, I will still get something which is decreasing. So as I draw my curve as a function of x, where x goes from 0 to 1, my curve starts at this point. When I substitute x equals 0, I get 1. When I substitute x equals 1, I get 0. And I know the curve has to be decreasing through that region. So there's no minima or maxima or anything like that. I'm just going to draw some generic curve that connects these where it is decreasing. Now, if I write the relation between x and y for these things, this curve this curve is represented by y equals 1 minus x to the 7 to the power of 1 over 3, which is equivalent to x is equal to 1 minus y cubed to the power of 1 over 7. Now, if I think about what this integral means, I'm integrating like this, right? I'm computing the area by computing heights of infinitely thin rectangles. But I can just as equally compute that area by using horizontal rectangles. So I could also integrate this way. And this amounts to writing this area in terms of the y variable, 1 minus y cubed to the power of 1 over 7 dy. But you know, the variable of integration in an expression like this is just a dummy variable. And you'll notice that this is the second part of the thing we're actually trying to integrate. So my final answer to this thing is that the full integral from 0 to 1 of this quantity is going to be equal to 0. And that's just because the two portions, the two portions of this integral are going to cancel out. If we think of it as two separate integrals, then they actually represent the same geometric area. They're just written in two different ways. I'm not sure, like, I don't really know exactly what the important intuition here was to get to this part, but yeah, I stumbled around a little bit, but you know, if I go back and rewatch this recording, I think I did say something about trying to interpret this as the area of a subset of the square. Although I suppose this function might become negative at some point, so it's not really a subset of the square, it's a subset of some rectangle. Yeah, I think just eventually, you know, plotting things and fooling around got me there. And this is actually this type of change in perspective is kind of what the difference between the disk method and shell method for volumes of revolution is all about. Being able to switch between these two perspectives is really important in understanding why both of those work. Thanks for watching.